adjusted to cater for the senior 5 students who are still at home and the senior 6 students that are day scholars. Please make sure that you wake up the senior 5 students and the senior 6 students to continue learning with us. Yes, I want also to take this opportunity to remind you that COVID-19 is still there, and therefore, for those that are in school and those that are at home, let us continue to observe the SOPs. Wash your hands, put on your masks, and keep a social distance. We shall be continuing, and today we are looking at physics. We are going to look at refraction through a lens or through lenses. And this is a new topic. However, we have been looking at refraction through prisms. We already know what refraction of light is, and therefore we are only changing the concept to look at the lens. I will go straight to remind you that the last time we looked at deviation through a small angle prism, and we were able to derive an expression for deviation through a small angle prism of non-refractive index and, of course, refracting angle. We are now going to proceed and look at refraction through lenses. One would ask, what is a lens? What is a lens? And we want to say that a lens is a material. A lens is a material that is made of glass. A material that is made of glass that is bounded by 2 spherical surfaces. That is bounded by 2 spherical surfaces. If, for example, I have this as my sphere, people usually call them circles, and they have another one here. These different circles or spheres, as we'd call them, have different centers of curvature, as we shall later call them. And we know that for a circle, the distance from the center to the circumference is the radius. This can be called R1. Similarly, this circle here has a center. If it is circle 2, and its center is C2. Again, the distance from its center to the circumference on one side is the radius, and we can call this R2. Now, this part bounded by the 2 spherical surfaces that I'm shading gives us what we are calling a lens. It gives us what we are calling a lens. Gives us a lens, and we shall actually shortly look at this type of lens as the convex lens. As the convex lens. Definitely C1 and C2 are centers of curvature. For the 2 spherical surfaces. And also R1 and R2 the radii. Radii is plural for radius of curvature, and the radii of curvature of the spheres. So we are saying a material that is usually an optical medium, someone could call it an optical medium, that is made up of glass and is bounded by two spherical surfaces, as you can see, is what we call a lens. The shaded part gives us a lens. The shaded part there gives us a lens, and this is a convex lens, as I've already said. There are two types of lenses. Students should take note that there are two types. These two types, the first type is this one that we are calling the convex, otherwise looked at as the converging lens. We have the convex, otherwise looked at as the converging lens. And this type of lens as we are shortly going to see, is thicker in the middle thicker in the middle and gets thinner towards the edges. There are various types. We have what we shall call the converging or the biconvex. And this is drawn like this. We have the plano-convex. This is halfway. And we have the converging meniscus. Which we can draw like that. The biconvex can also be called the equiconvex. One can call it the equiconvex lens. And they are still correct. We have said that a lens is a piece of material that is made of glass and bounded by two spherical surfaces. And we have said the features of a lens include the centers of curvature, the radius of curvature or the radii of curvature. And now we are talking about that there are two types of lenses. The first type that we have seen over here is a convex lens. We shall shortly be seeing how the convex lens affects incident light. The other type of lens is the concave. The concave lens, we can also call it the diverging lens. The word converging and diverging are opposite. Now for the concave lens, we have the biconcave, which before we look at the diagrams, we said this one is thicker in the middle, as you can see, and becomes thin as you move towards the edges. On the contrary, the diverging lens is thinner in the middle it is the opposite, thinner in the middle and gets thicker towards the edges. We also have three types. The first type is the biconcave, which we can draw like this. The second type is the plano concave, which is half of the biconcave. And the third type is the diverging meniscus. Diverging meniscus which we can also draw like that. Yes, lenses refract light, and we shall shortly be looking at how they affect incident light. The senior 5 students and the senior 6 students that are following this program and these lessons want to continue to thank you and remind you that we are determined to continue serving you and learning with you to ensure that you can be the best that you can become. We are looking at lenses, and we are saying there are two types of lenses. Meanwhile, the candidates following this program should be able to capture the information on the BB. We have the convex lens, which we have said is also called the converging lens. We are going to see how does it converge light to where. We have the concave lens, which we are also calling the diverging lens. How does it diverge incident light? As we prepare to go to the next phase of the lesson, I want to say that when light is incident on lenses, it is refracted. It is refracted to a common point if the type of lens we are talking about is convex. And if the type of lens we are talking about is concave, the light will be diverged still to appear to come from a common point. In our next phase, we are going to look at how do these lenses work? How do they work? How do they work? I want to assume that we have been able to capture what a lens is, if they ask you to define a lens or to explain what you understand by the term lens. We have said it is a material that is made of glass and is bounded by spherical surfaces. The spherical surface of the sphere with center C2 bounds this other side, and the one with center C1 bounds the other side. And what is obtained, the shaded region here, gives us what we are calling the lens. C1 and C2 are centers of curvature of the two different spheres. In R1 and R2 are the radii of curvature of the sphere. Remember that if we have a circle, the distance from the center to the circumference is the radius. And the center is labeled as C. the center of curvature. We proceed with our lesson, and this time round, we are going to look at how does the lens work. If someone asks you, how does the lens work? They are actually looking at the action of the lens. In other words, they are looking at how does the lens work. There are two types of lenses, remember. We shall look at how they work. If I use this line to represent my convex lens, if I use this line to represent my convex lens, I can use my convex lens at the center there, such that any incident light that hits that line is assumed to have reached the lens, and I'll consider two incident light rays on either side. On either side. If light is incident that way, candidates should note that they are expected to use rulers. They should not copy that the teacher is using a free hand. You are expected to use a ruler, and when you use a ruler, you get a perfect diagram of what I am illustrating. You get a perfect diagram of what I am illustrating. When light is incident on a convex lens, it is refracted to pass through a common point. This common point is called the principal focus. The principal focus of the lens, otherwise also called the focal point. So we are seeing that the convex lens refracts light to one common point called the focal length, or called the principal focus, and this principal focus is real. I will re-emphasize what a real principal focus means. It means that light rays converge there directly after refraction. Light rays converge there directly after refraction. And we can say that the convex lens refracts light or converges parallel incident light rays to one point called the principal focus. To one point called the principal focus. If we look at the concave lens, this is the reason why the convex lens is called a converging lens. It brings together all the light rays to one point. The convex lens, on the other hand, if I consider this diagram and I again illustrate a small representation of my convex lens at the center, for any ray that is incident parallel to the principal axis, The principal axis is the line that passes through the center of curvature in the optical center, which we are going to talk about next. This type of lens refracts light, diverging it away. It refracts light, diverging it. Light comes, it is refracted, and this light appears to be coming from some point. It is refracted, and it appears to be coming from some point. This point where the light rays meet the principal axis is now the virtual principal focus. Even this should be refracted here to appear to come from there. Even this should be refracted here to appear to come from the same point. Now you notice the difference here, that light rays had to be extrapolated to converge at point F. The rays had to be extrapolated to converge at point F, and therefore we say that this is a virtual principal focus. Virtual means that in reality it is not there, it is imaginary. So we can say that the concave lens diverges. It diverges incident, diverges parallel, incident light rays, diverges parallel incident light rays, and they appear to come from one point called the principal focus again. And this point is F. However, we are saying that the principal focus of this type of lens is virtual, whereas the principal focus of the convex lens is real. Whereas the principal focus of the convex lens is real. A common question that can be posed here to the candidates is, you can be asked to distinguish between concave and convex lenses. In other words, they want you to compare the difference between a convex lens and a concave lens. If that question is asked from these two diagrams, one can say that a convex lens converges incident parallel light rays to one point, and a concave lens diverges incident parallel light rays to one point. One can still say that a convex lens has a real principal focus, and another one can say that a concave lens has a virtual principal focus. One can still say that a convex lens is thicker in the middle and becomes thin towards the edges, whereas a concave lens is thinner in the middle and grows or becomes thicker as you move towards the edges. Those are three different distinctions that one can bring out. In other words, we are saying that concave lenses affect incident light by diverging it to appear to come from one point that we are calling the principal focus, whereas convex lenses refract light to make it converge at one central point. In our last lesson, we saw that lenses can be formed in such a way that we regard them as small pieces of prisms with several small angle prisms that are packed on top of each other. And we saw that it is from that arrangement that we can get an expression for the deviation of a small angle prism, which we looked at in our last discussion. And therefore it implies that the deviation of light is usually as a result of deviation that is caused by a prism at the point of incidence. I want to look at a few terms that are used in lenses and their definitions. A few terms that are used in lenses and their definitions, and we can begin by looking at the center of curvature. The center of curvature. Remember where we started from? We started by drawing a sphere, and we said that sphere must have a center, and that center is the one we are calling the center of curvature. The center of curvature can be defined as this, as the center of the sphere as the center of the sphere or of the spherical surface This is the center of the spherical surface from which the lens forms part. The center of the spherical surface from which the lens forms part. Sometimes someone can say of which the lens forms part. Sometimes it can be defined in plural, and we say that these are centers of the lens or of the spherical surfaces from which the lens forms part. If it is centers of curvature, if they say centers of curvature, but if it is center, we define it in singular as one center. The second term is the radius of curvature, and we are going to look at both of them. Remember, we said that a lens is formed by two spheres combining, so we can look at this as radii. But even if they said radius of curvature, the candidate should be able to define it singularly. We can say that this is the radius of the spherical surfaces of which the lens forms part. The radii of curvature can be seen as the radii of the spheres, or the radius. If it is the radii, we maintain radii of the spherical surfaces of which the lens forms part. The other term that we can look at, remember we are talking about this is obtained for two different spheres. So we are saying it is the radii of the respective spherical surfaces of which the lens forms part. The other important part or point is the principal axis. This is the central line here, and it passes through an important point called the optical center. We can say that this is the central line that passes through the two centers of the spheres whose surfaces form the lens. I can illustrate a few points here by labeling. If I use this type of lens, this point that I'm going to call O is going to be called the optical center. And because we saw that a lens has two surfaces, one purportedly supposed to be the surface that comes from this other sphere, this would be an extraporation. This time, let me make it an extraporation. And this extrapolated also to give us another surface of the second sphere. It implies that the centers, two of them, and if this is center 1, we say this is center 2. But ideally, we'll discover that for any given lens, if you take that reasoning, for any given lens, it will have two centers of curvature, this one and that one. And we are saying, if I call this line A, B, the line AB is the one we are calling the principal axis. The principal axis. The line AB is the one we are calling the principal axis. The shaded part is the one we have called the lens. And point C1 and C2, we said they are centers of curvature. They are centers of curvature of the two different spheres. So we are saying the central line, AB, that passes through the two centers, passes through C1 and C2 of the spheres, whose surfaces form a lens, as you can see, is what we are calling the principal axis. It does not mean that when you are defining the principal axis, you must draw the diagram, but the diagram is drawn to emphasize a few things. One, to show us our next point, which is the optical center, and two, to re-emphasize the centers of curvature. It can also be defined as the line that passes through the optical center and the center of curvature of the lens. It is the line that passes through the optical center and the center of curvature of the lens, if we take it simply. Our next term is the optical center, and I will once again request that I clear off the part that was showing us how a lens works. We saw how two different types of lenses we have looked at today can actually refract light. And we have said that convex lenses refract incident parallel light. The light is parallel to the principal axis, that horizontal line that passes through the optical center that you now know. When light is parallel, the convex lens will refract it to converge or to meet at one point. Converging is a meeting point. Diverging, it means you are moving away from one common point to different destinations. Converging, you are moving from different areas and you meet at one common point. So the next term we are looking at is the optical center. And by positioning of where you see it, it suggests that we can say that it is a point in the middle of the lens. It is the point in the middle of the lens that is optical center. You can say that this is a point in the middle of the lens as I have just shown it to you, and it coincides with the two principal axes. The point in the middle of the lens coinciding with the line that we have called the principal axis. In other words, the principal axis passes through that point. We can say it's the point in the middle or in the center of the lens, but we are avoiding repeating the word center. That's why we use middle, through which the principal axis passes. If you don't want to use coinciding, you can say through which the principal axis passes. The next important term is the point we have called the principal focus. And I must say that I told you that can also be called the focal point. If they ask you to define the focal point, you should not say, I have never heard about it. When we look at the two different lenses that we saw at the start of this lesson, we note that we said that one converges light to this point, and the other one diverges light to appear to come from that point. So we can define it to cater for both. If they say, define the following terms as used in lenses, and they mention principal focus, your definition, if they say, define the terms as used in lenses, they are leaving the question open for the candidate to define it in such a way that it caters for both types of lenses. If they say, define the terms as used in convex lenses, your answers should be restricted towards the convex lens only. If they say, define the terms as used in concave lenses, and among the terms there is principal focus. Principal focus the definition changes depending on the type of lens they're asking. I've said it can be restricted when they mention the type of the lens, and it can be open when they don't condition themselves to any type of lens. So we are going to define it to cater for both lenses. And we have already said that it is a point along the principal axis that is clearly known. But for a convex lens, where all the incident parallel rays are refracted to pass, that is for a convex lens. And for a concave lens, where all the incident parallel rays appear to come from after a refraction. So we can say that this is a point. It is indeed a point, one single point. It's a point along the principal axis. It's a point along the principal axis. Where rays that are originally parallel to the principal axis, where rays originally parallel to the principal axis pass after a refraction or appear to come from after refraction for the convex lens and the concave lens respectively. This definition caters for both types of lenses. If it is a convex lens, we are saying the principal focus is that point along the principal axis, where rays that are originally parallel will pass after refraction. If it is for a concave lens, we say it's the point along the principal axis, where rays that are originally parallel to the principal axis appear to come from after refraction. You may refer to the diagrams that I showed you when we are looking at how the convex lens works. You may refer to those diagrams. The next point we can talk about is the focal length. I can illustrate a simple diagram here with whether it is with a concave lens or a diverging lens. If this point is the focal point, I can just illustrate with one ray, then this is what we are calling the focal length. It is a distance, therefore. It is a distance, therefore, that is measured from the optical center to the point where light rays refract the principal axis, and that is the focal point. So we can say that this is the distance between the optical center and the principal focus. And the principal focus of the lens, if I want to be brief. the distance between the optical center and the principal focus of the lens. If you don't want to use principal focus of the lens, you say it's the distance between the optical center and the point on the principal axis where rays originally parallel converge after refraction. You are basically referring to this point. You can say that it is the distance between the optical center of the lens and the point along the principal axis where rays originally parallel converge or appear to diverge from. If you notice our definition here, that would be referring to the principal focus. The distance between the center of the lens and the principal focus of the lens. As we proceed, we can look at two more terms. And we move towards winding up or into the last part of the lesson. The other term that I can talk about, I can fix it here, is called the focal plane. This is a rare term. It is a plane that is perpendicular to the principal axis. We can say this is a plane that is perpendicular to the principal axis and passes through the focal point. And passes through the focal point. It is a plane that is perpendicular to the principal axis and passes through the focal point. The last term on the terms that we can look at is the power of a lens. Power of a lens. This can be defined as the reciprocal of the focal length of the lens in meters. The focal length must be in meters. It can be defined as the reciprocal of the focal length of the lens in meters. The reciprocal of the focal length in meters, and by the formula we say that power is equal to 1 out of focal length, but the focal length must be in meters. Power is measured in units that we call diopters, denoted by symbol capital D. And I can put an example. If the focal length is, for example, 10 centimeters, if the focal length is 10 centimeters, find the power. Find the power. We are saying to find the power, we must convert that focal length into meters and get its reciprocal. So we are saying that power will be equal to 1 out of the reciprocal of the focal length, 1 out of the focal length in meters, 10 out of 100, which is actually 100 out of 10, and this is giving us 10 because when we take this, we get 0.1, which is the same as 1 out of 10, which is 10, and we say the units are called diopters. The units are called diopters. I want to definitely give a reading assignment with a hint as we come to the end of the lesson. We are supposed to look at image formation through lenses. Just like we look at formation of images through mirrors, or we looked at that, lenses form images. And if I begin with this one as we wind up, the diverging lens, why? Because it has a unique image and only one of the kind. Diverging lenses form, if I have an object here, they will form an image that we can get by, we said it diverges light rays, and these light rays appear to be coming from a point that we shall call F. And we have another common ray that must pass through the optical center. This ray usually passes without any deviation. Where these two rays meet here should be, however small, should be illustrating an image that is virtual, that is erect, that is diminished, as can be clearly seen, and that is formed between the optical center and the focal point, where O is the optical center. Diverging lenses strictly form a virtual image and must be between O and F, irrespective of the position of the object. The reading assignment that I'm leaving you with is to make sure that you practice on drawing the images formed by the convex lens. Read and draw images formed by the convex lens. When we meet in our next lesson, we shall start from there. I want to thank you for following this program and ask once again that the S5 students should focus now on the lessons, and the S6s should not keep away if they have an opportunity to watch these programs. I wish you the best. God bless you. Keep following the SOPs. Bye-bye.
Bw'osomeseza omwana wo mu masomero ga Giant Schools omuli kampasi y'Ebombo Kalule n'ey'e Kabalagala tobana bweraliikirivu bwonna olw'omusingi okutambuzibwa ebyenjigiriza n'ensoma y'abayizi ey'omulembe. Mu masomero gaffe gano gonna tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuuka ku siniya ey'omukaaga, nga tusomesa abaana okuviira ddala ku mutendero gwa kindergarten okutuuka ku kibiina eky'omusanvu. Tulina abasomesa abakugu mu kubangula abaana n'okubateekateeka. Ebibiina abaana mwe basomera eby'omulembe omuli buli kimu ekikwata ku ebyo bye basoma, ebisuula ebyazimbibwa obulungi, ebigazi ate nga biyonjo. Okumanya ebisingawo tukubire ku nnamba z'essimu ez'owammanga.